energy, I got two types here. We're not dealing with rest energy. So this got kinetic and potential. So this is conservative work plus change in kinetic plus change in potential is equal to change in kinetic. So this comes from here, and this comes from this. I didn't derive this at all in front of you. This is just, I'm just asking you to accept that non-conservative work causes energy not to be conserved. More specifically, non-conservative work is equal to the change in energy.
Let's just say that again.
Non-conservative work is equal to the change in energy. The total, change in the total amount of energy.
We ain't doing it. Well, we are, sorry.
I mean, I'm just asking you to accept that, not deriving that. I'm just
Mhm.
stating that we're gonna pretend like that is absolutely true. Because if that's not true, then there's a lot of physics that falls apart and, you know, planes fall out of the sky. I don't know why I wouldn't fly out on that one. Drones fall out of the sky. All right, so I have kinetic energy, change in kinetic energy on both sides. So I'm just gonna subtract it and get rid of it. I'm gonna bring this change in potential over to the other side. So I subtract it. So I end up with conservative work is equal to the negative change in potential energy. So I now have the total work equal to change in kinetic, non-conservative work equal to the change in energy, and conservative work equal to the negative change in potential. Those are the work-energy relationships. And it might not seem that way right now, but it is going to make our life a little bit easier, probably next Tuesday. It'll make you forget all about what happened on the test, for better or for worse. So I need to point out one other thing here. We talked about the change, we talked about the formula for kinetic energy. And by the way, what is the formula for kinetic energy?
1/2 mv squared.
Not quite as rousing as before.
Sorry.
People going in rounds. Let's try that one again. What's the formula for kinetic energy?
1/2 mv squared.
Well, time lag there, but they got it. Certain voices I didn't quite hear, but. We have a formula for rest energy, the m sub 0 c squared. But I haven't talked about the formula for potential energy. We'll recognize here, my conservative work is just my conservative force times displacement is equal to negative change in potential energy. It turns out that every conservative force has its own potential energy formula. This will correspond to a potential energy formula. I guess generic formulae. So if ever I ask you what's the formula for potential energy, the correct response is which one? There's one formula that Hewitt uses quite a bit in chapter 7. Some students get the impression that that is the formula for potential energy. It is the formula for one of the potential energies. So if we're dealing with weight as the force, that's the formula he uses in chapter 7. So I'm just going to briefly put these up here. So we got the conservative force, and then we have the potential energy formula. So if we're dealing with weight, the potential energy formula is mgh. I'm going to put a little plus c out here. This is plus a constant. It's not the same c as that. I'll explain that for this next week. If we're talking about the generalized gravitational formula, F sub g, the potential energy formula is negative g m1 m2 over r. We haven't done the generalized gravitational formula yet, so this might look completely foreign to you. And ideal elastic. The potential energy formula is 1/2 lowercase k delta x squared. At some point, though, always tack on a constant for the end. We will be dealing with all of these in this course. We are going to derive what's known as the Schwarzschild radius when we get to chapter 9 or 10. In other words, we are going to derive the formula for how big does the Earth need to be, or how small does it need to be, in order for the Earth to become a black hole. We will use this. How small does the Sun need to be in order to create a black hole? We're going to be using this. And by the way, in case it worries you about our Sun becoming a black hole, based on current theories, our Sun cannot become a black hole, but we'll talk about that later.
I came into class so worried about that. I'm glad
Yeah.
my cares have been put to rest.
Eventually, when we get to thermodynamics, that's the fun one. Second law of thermodynamics, that is the end of everything. So, good times ahead.
I have a question. Since we're done with chapter 6, is that quiz gonna be on the 12th?
If we're done with 6, what?
Will that quiz be on the 12th? For chapter 6?
Would be on
Will it be on the 12th?
the 12th?
Will the chapter 6 quiz be on the 12th?
Oh, sorry. Let's just get through the test before we start talking about the next quizzes, but 6 and 7 quizzes will be together.
Oh, okay.
The test next week, while I'm thinking about it, the test next week, because the class is only once a week, I can't do we're only doing the test, so we'll do the test first, answer last minute questions, do the test, then we'll do class next week. It's not a done with the test and go. So, just, but you might want to prepare yourself.
Did you say you discussed talk about it a minute ago?
I don't think that's what I said.
That's bad.
But we do have it recorded, so we can always play back the tape.
Hearing that.
Oh, shit.